In this video, you are going to learn what Kotlin sequences are, how to use it, and how a sequence differs from using normal operations on a list. We would create a list of integers. So we can say var, let's call it scores, is equal to list of, we don't need this, we can say 1, 2, 3, 4, 5. So we have numbers 1, 2, 3, 4, 5. So we would be using this list to explain what sequences are in Kotlin. If you have programmed in Java before, just know that Kotlin sequences are very similar to Java streams. In fact, if you understand Java streams, you can say you almost already understand Kotlin sequences because the differences are very little. A Kotlin sequence represents lazily evaluated collections. So if we want to work on this call as a sequence, all I need to do is dot as sequence. I can keep chaining operations and work on the elements of this list step by step. So for now, let's just print out each element in this list. If you're familiar with lambda expressions in Kotlin, you would know that we could use it. So it represents what is passed down. So let's print this out. So we collected each element and printed it out one after the other. But sequences are more powerful than this. So over here, I can say map. So I can use map to transform the elements to a desired form that I wish to use. So I can say for each element that comes down, multiply it by 2. So I run this. So you would have 2, 4, 6, 8, 10. We could also filter it and print out only numbers greater than 5. So currently, when we run this program, we have 2, 4, 6, 8, 10. Let's filter it. So we'll say filter and only allow the elements that are greater than 5. Now we should see 6, 8, 10. And that is what we saw. When you look at a sequence, you have what they call the intermediate operations. These are the operations that normally work on the elements of the collection. Then you have the terminal operations. The intermediate operations are not executed until the terminal operation has been called. So let me give an example. So what we did here is, as it is performing the map operation, it will print out mapping, and as it is filtering, it will print out filtering before the terminal operation. So let's run this. So we see mapping, filtering, and then we see all that. I will explain why the output looks like this. But before that, let us remove this for each and run this. If you notice, you find out that nothing was outputted. That is because Everything here is an intermediate operation, and nothing here is a final operation. Another final operation is called max. This returns the maximum value after mapping and filtering. So let's run this. Now, if you notice, once a terminal operation is called, then the intermediate operations can now be run. So this returns an integer, so we can say val max number. So we can come over here and print it. So now when we run this, we can see the maximum number, which is 10. Terminal operations normally return some form of result or perform the last operation for the sequence. Intermediate operations normally return a sequence. So this returns a sequence, and this works on the return sequence. You could also reuse sequences. What do I mean by that? Once we remove this max, we can rename this to scores sequence. So now we got the sequence of scores. We put a map, put a filter, and as I told you that filter returns a sequence, we can assign that sequence to this variable. We can come here and print score sequence dot max. So we run it. That way it's easier to read. I can further say score sequence dot map it plus 2 for each. So multiply everything times 2, get me the ones greater than 5, and add 2 to them. I can get the same scores sequence dot map it plus 5 for each. Oops. So it's the same score sequence, but I can use it multiple times. So this is the first output, and this is the second output. So you can see that I can even pass this to a method or function. So let's say we have a function. So fun add num. So we'll come over here. We have our sequence, our addition. It returns back a sequence. So I can say the sequence dot map add the addition to every value in the sequence. So over here, I can come here and say add number to sequence, score sequence, and let's say 10. Since it returns back a sequence, I can say for each element, print it out. And then run this. So we would see 16, 18, and 20. The second thing I would like to discuss is the difference between Kotlin sequence, and normal operations on a list. So for example, I could come here and say scores.map it times 2 dot filter it greater than 5. Let's arrange this. So we can remove this, bring this close. So if you might ask, what is the difference between this and this? So in a sequence, each operation returns a sequence. And when you do it directly on the list, each operation returns a new list. So at the end of this, what is being returned is a list. So if you highlight over this filter, you would see that this is returning a new list. So if I come and print scores list, can make this a val, we would see that what this returned was a new list. However, when we come here and have scores sequence, when we print out score sequence, what we get is a sequence and not a list. A sequence is lazily evaluated. What do I mean by lazily evaluated? Now let's give a very simple example. First, we will start with the list. So we have our scores.map. Let's have it for each at the end and print out each element. Or while printing out the elements, let us print out for each it. So we have this. Almost all the sequence operations are also available for the collection methods. And each collection method can be seen as a terminal operation because each collection method returns a list of the type of collection. So once I say .map, it returns a list. So let's run this program. So let's see what happens. This is very important. So right here, I called the operations, the methods on the collection. I didn't use sequence. So let's see the difference. Now, I saw map 1, map 2, map 3, map 4, map 5. Then we went down to filter 2, filter 4, filter 6, filter 8, filter 10. Because we had mapped each element times 2. Then we went to for each 6, for each 8, for each 10. So if you look at it, what happens is that the whole list scores as a whole comes down to map at once and is done with it before coming down to filter. So that means that even if this list was a list of 1 million elements, the whole 1 million elements will come down to map before coming down to filter and before printing out. Now let's try this same operation, but in this case with sequence. So we could easily come here, the same thing, but the only difference is that we'll put a sequence before putting the operation. So we could come over here and comment out this so that we don't focus on it. So we're going to focus on this. So let's run it. A different output. We see map 1, filter 2, map 2, filter 4, map 3, filter 6, for each 6, map 4, filter for each. So let's explain what is going on here in case you feel a little bit funny. A sequence helps us perform operations on a collection lazily. By lazily, it means I perform operations on elements when I need them. It doesn't send the elements as a whole. So it sends 1 first, 1, the first element. So 1 comes here. It prints out map 1. It multiplies 1 by 2. Then it comes here and prints out filter 2, because by this time 1 is already multiplied by 2. Now it filters it, it doesn't reach the for each, so it goes back up. 2 comes, prints out map 2. When it comes here, it prints out filter 4 because 2 had been multiplied by 2, which means 4. So it prints out filter 4. Now 4 isn't greater than 5, so it doesn't print out for each. The next element is 3. So it prints out map 3, which you see over here. Now it comes here, 3 has been multiplied by 2, which is 6, filter 6. Now is 6 greater than 5? Yes, so it comes here for each 6. That's why you see for each 6 there. The next element 4 comes on. Map 4, filter 8 for each 8, and it goes on. Now you can see that each element is processed one after the other. This has an advantage because it's more efficient. There is something called any. It's also a terminal operation. So if I say any, it returns a boolean. So I'm saying, is there any number here that is greater than 5 and even? Now let's run this. Can you see that the output is shorter? So let's run this mentally. So we have 1, it prints out map 1, filter 2 because we multiplied by 2. We found out that it's not greater than 5, though it's even, it's not greater than 5. So we'll go on to map 2. 2 will come over here, 2 times 2, 4, but 4 is not greater than 5, so we'll go over to the next element, 3. So we'll come over here, 3 times 2, 6. 6 is greater than 5. And at this moment, 6 is greater than 5 and it is even. So we have found what we're looking for at this point. Now, because it's a sequence, we didn't need to go to the other elements. So imagine this was a list of, 500,000 elements. Just giving you raw numbers, nothing in those numbers. So let's imagine we have a big list. Assuming we come over here and remove this sequence. So we are working on the collection directly. You see, we have a longer output. It takes the whole list and finishes the map operation on each element of this list. Each element of this list, no matter how big it was. You see why this is going to be really complex? So after doing that, it came down to filter. Okay, filter the ones greater than 5 after multiplying it by 2. Now, is there anyone greater than 5 and even? But the thing is that he ran this on every single element and ran this on every single element before coming here. So by the time you have a larger list, probably something like 1, let's say 1 to 100. So we have now values 1 to 100. We see we have a lot of values now. This is a lot. Just because we're just looking for crying out loud, we're just looking for an element that's greater than 5 and even. But instead, we used so much computation power. Of course, this is a small program, so you won't feel it. If we use sequence for the same collection, we find that we have a smaller output, more efficient because we're processing each element one after the other. So it comes just like Java streams. There are much more wonderful operations you can do with Kotlin sequences, as well as methods on Kotlin collections. But the main important thing is to understand that there's a difference between sequence and working on the collection. Depending on what you want to do, sometimes working with collections directly is better. Sometimes working as a sequence is better. It depends on your use case and your scenario. So for now, if you like this video, give it a thumbs up and consider subscribing for more content like this. I will put a link below where you can get more information on Kotlin sequences. Do have a great day.